Hello everyone. Today in this session let's discuss about addressing modes. We know the CPU can access the data in different ways, whether the data may be present in the register or it is present in a memory location or it is given directly as the part of the instruction. Therefore, the various way of accessing the data is called as addressing modes. So based on whether they are stored in register or in memory location or it is directly given, we deal with different kinds of addressing modes like immediate, register, direct, register indirect and indexed addressing modes. Let's discuss about immediate addressing mode. So this immediate addressing mode is the simplest and easiest addressing mode where the data is given directly as the part of the instruction. So here you can see the instruction which is written like this: move a comma symbol, we have used a hash, nothing but pound symbol we are using, followed by the data. So this symbol what we are using, hash symbol or pound symbol, it is to say that this is a immediate addressing mode. So this instruction says moving the data 25 into A. Or else you can go with the second instruction, we are using move R4 comma pound 62, we are loading the decimal value 62 into R4, whereas 25H when we are saying it is hexa value, right? So next we have decimal value. Similarly we have next instruction, move B hash 40H, again you are moving 40 into B. Next you can see we have an instruction, move DPTR data pointer register, and we are using 4521H because DPTR is a 16-bit register, hope you remember. So now we are using 16-bit data. So this is the example which can explain your DPTR easily. So we said DPTR is a 16-bit register. So now we have taken the 16-bit data. So now this DPTR is classified into divided into two sections. One is DPH and the other one is DPL. So L is to store your lower byte and H is to store your higher byte. So in this data what we have taken 2550 we have taken. So 50 is your lower byte and 25 is your higher byte. Therefore, the lower byte of data you are moving into DPL and higher byte of data you are moving into DPH. So if you are exceeding the data size, like if DPTR can hold only 16 bit of data, if you are exceeding more than 16 bit, then it becomes illegal. Now you can look into this example. It is saying move DPTR hash 68975. So this is more than 16, almost 20 bit of data we are taking, right? So when you are exceeding the data size, because DPTR can hold only 16 bit of information, when it is exceeding more than 16, then it becomes illegal. So in immediate addressing mode, it is the easiest way of addressing it, where your data is directly given as the part of the instruction, where to say that this is immediate addressing mode, you will be using a symbol, pound symbol or hash symbol after before your data, right? So here you can go with a different example, and we have used DPTR, where DPTR is a 16-bit of register, so you can use 16-bit of data. Let's move the next kind of addressing mode. So that is register addressing mode. So in register addressing modes, we are using only registers to hold the data, right? So for example, you can see move A comma R0. Here you are moving the content or copying the content of R0 into A. Similarly, from A to R2. Next you are adding the data which is present in R5 with accumulator A. Next you have adding the content of R7 with A, and again you are saving the content which is present in A into R6. So now the register addressing mode is the one where you are using only register to manipulate your data. So these are the different examples you can have. When we are using register, we must careful about using the size of the register. So now the source and destination should have the same size, like maybe it is a 8-bit or it is 16-bit. For example, if you are writing an instruction move DPTR comma A. So this is invalid because A is a 8-bit register and DPTR is a 16-bit register. So this is called as size mismatching. So whenever we are using the register, we must be careful about their size. For example, you can look into the this section of your programming where we have said that DPTR is a 16-bit of register and it is having the data 25F5. Now the lower byte of information you are storing into R7 and higher byte of information you are storing in R6. So now lower byte is nothing but your F5 and higher byte is nothing but your 25. So now register addressing mode is the one where you will be using the register to manipulate your data, right? So now the size of you should careful about the size of the registers you are taking between your source and destination. So we said in addressing mode whether the data is given directly or maybe it will be stored in register, it may be taken from the memory location. In the previous two cases what we have discussed, it is about your immediate addressing mode where the data was directly part of the instruction, and next we had register addressing mode where your data was present in the register. Next we will go with the next kind of addressing mode where we are using these addressing modes to access the data from the memory location. The first kind of addressing mode we deal with is direct addressing mode. So in this direct addressing mode, we know the 8051 can support 128 bytes of RAM, right? So this 128 byte, what we have said it as 002 7FH, it is classified into three sections like 002 1F, what we are using, it will be assigned for register bank and stack. Next we have 20 to 2F which are for bit addressable, and next we have 30 to 7F which are for byte sized data. So this 128 byte of RAM what we are using, it can be accessed using direct addressing mode. In immediate addressing mode, the data was given directly as the part of the instruction, whereas in direct addressing mode, the memory location where the data is present is given directly. That is why it is called as direct addressing mode. In direct addressing mode, the data in a RAM memory location whose address is known and this address is given as part of your instruction, whereas in immediate addressing mode, the data itself was the part of the instruction, right? So to make out the difference, you can use this symbol pound. If you are using this symbol, it is immediate addressing mode, where in the other case where the address of the location where your data is present, that is given, that is called as direct addressing modes. Now you can see here the different instructions we have taken. Move R0, 40H. So this instruction says the RAM location 40H, what we have, the data which is present in that location has to move to R0. The next instruction says that the data which is present in A, it has to move into the RAM location 56H. Similarly, the data which is present in 7F, it has to be moved to, right, moved to RAM location R4. So now that 128 byte of RAM which can be easily accessed by using the direct addressing mode. The direct addressing mode says the location, the memory location address where the data is present is given directly as the part of the instruction, whereas in immediate, the data itself was the part of the instruction. We are using register banks, so already we know that the register banks can be named between R0 to R7. Right, so already we have discussed about 128 internal RAM organization. It is classified into three sections. One is register bank, bit addressable and byte addressable. When we are using register bank, it will be named as R0 to R7. So now we have shown few instructions over here. The first instruction, what is written as move A, 4, it is same as move A, R4. Which means that we are copying the content of R4 into A. So this 4 is nothing but indicating the register R4. Similarly, when you say move A, 7, it is like you are moving the content from R7 to A. Similarly, to move A, 2, it is nothing but it is indicating R2, and similarly you have R0, it is nothing but the register R0. Just go to this part of the section program section where you can understand it easily. So we said 4 indicates register R4, 7 indicates register R7, 0 indicates register R0. Now we are moving an immediate value 5 into register R2. Therefore the R2 will be holding the value of 5. Right. Next what I am doing, move A, 2, which says that 2 is nothing but R2, register R2. The content which is present in R2, it should be moved to A. right? Similarly, next I am writing, it is written move b comma 2, which says that the content present in R2 it should be moved to b. Therefore now b is also holding 5. Next what we are doing, the content which is present in R2 it is moved to 7. So 7 is nothing but register R7, right? So now this instruction says that you are moving the content from R2 to R7. Nothing but the source and destination what we are using both are register, which is a invalid instruction. So this is about your addressing mode. The first basic we have taken as immediate addressing mode. Next we have register addressing mode, and this is about direct addressing mode.